Hey guys, I'm here to help you complete some of the notes for the section 10.2 find arc measures. I'll run through some of these definitions first. Central angle of a circle is an angle whose vertex is the center of the circle. All right, so my central angle would be this one right up here. The vertex is the center of this circle. All right, so it's just like any other angle we've encountered, it's just in a circle. That's the only difference. Minor arc, part of a circle measuring less than 180, or less than half. So what I have drawn up here in my central angle is a minor arc, what I'm tracing right now. All right, anything less than halfway around. Which means that what's left over, all of this that I'm tracing in blue, this piece around the circle is going to be a major. All right, and that's our next definition down here. Major arc, as I traced up here, is part of a circle measuring between 180 and 360. Can't equal 180, can't equal 360. It's between those two measurements. And next, obviously, a semicircle is an arc whose endpoints that are the endpoints of a diameter. Semicircle goes halfway around as opposed to a major or a minor. All right, semicircle, as it says, the endpoints are the diameter. So if I were to draw a diameter in my circle up here, we'll continue this radius across. All right, then my semicircle would have these two endpoints here. Here's my semicircle in blue. All right. As for measuring these arcs, to measure the minor arc, which we highlighted earlier, this little piece, it's just going to be the measure of the central angle. All right, so if this angle right here measures, let's say 90 degrees, right angle, that's telling me that this arc right here is going to be 90 degrees. So obviously the full arc all the way around would be 360. So therefore I can use that for my next measurement of a major arc, is the difference between 360 and the measure of the related minor arc. So if I want the rest of this arc, this major arc all the way around, I would just do 360 minus that minor arc. So I know that that major arc is 270. Last terms from this first page, congruent circles, two circles that have the same radius. So these two circles that we see on the right, radius of this circle and the radius of this circle, if they are congruent, then the two circles are congruent. And for the last one, congruent arcs, not only do they have to have the same measure, but the arcs of the same circle or congruent circles. So in that case, what they're saying is if they are on different circles, those circles have to be congruent. So this circle would want to have the same radius as this circle over here. Then any arc that I highlight on here is going to be congruent in both circles. There's some beautiful arcs. As for measuring those arcs, as I stated earlier, the measure of any arc, any minor arc, is going to be the same as the central angle. So as you can see over here on the right, this central angle, 50 degrees, which is telling me this arc AB, is 50 degrees. And notice the little marking they use to show that it's an arc over here on the right. That little curve above AB, the two endpoints that make up that minor arc. As you guys already know, the entire circle is 360 degrees. And the measure of any major arc is the difference between 360 and the related minor arc, as we stated earlier. So if I want to figure out how big this major arc is all the way around here, all I have to do is 360 minus that minor arc, which obviously leaves me with 310 for that major arc. And as we stated earlier, semicircle, 180. Next up is the arc addition postulate, similar to the segment addition postulate that we've talked about before. All right, it is the measure of an arc formed by two minor arcs is the sum of those two arcs. All right, so as we can see in the picture here, I could add up arc to get arc ABC, which would be this piece right here. I'd have to add up arc AB and arc BC. All right, don't forget your arc markings on top of those two. So for this first example, they want a couple things. They want to know, is it major, minor, semi, and this specific measurement. Before I go through and try to focus on what they're asking, I just want to focus on the circle. All right, and try to figure out what arcs I do know. First thing I notice is they gave me 81 degrees here, so I know right away that this arc is going to be 81 from N to P. All right, next thing I notice is they give me 73 here, so this arc is going to be 73. All right, and as they point out, this arc and this arc, those two central angles have to be congruent. They're vertical angles, so this one up here has to be 73. So now I have this arc for NM. Now the other thing I know is that this measurement right here, straight angle, has to measure 180, which means I can find this arc over here. If this side on the left is 73, then this side on the right must be 107, which means this arc is 107. Last piece I need is this one down here, PQ. All right, as I stated earlier, I know this is 180, so therefore I know this is 180. I have 81 on the left, 73 on the right, so I just have to add those two up and subtract them from 180. 180 minus 154 leaves me with 26 for that final arc. All right, now that I have everything filled in my picture, now I can go back and try to answer the questions. As for the actual questions they're asking about, first one they're asking about is MN. We already labeled that one, 73 degrees, and I know that one is obviously minor. Next one, NQR. NQR. For something like this, trace the letters in order. We're going from N to Q, the short way. So I'm starting at N, I'm going to Q, so that's 81 and 26 right now, and then to R. Well, it looks like since NR is a diameter on my circle, I know right away that's going to be 180. And if it's 180, then I know it's going to be a semicircle. Next one, start off by tracing your letters, Q, M, R. So I'm going from Q to M to R. So what I could do is I could go this way, Q to M, but then to get to R, I'd have to go all the way around the circle. So I know right away that is not right. That's incorrect. So I'm going to go back and I'm going to trace Q to M the other direction. So Q to M, which I can tell right away is a semicircle, and then to R. So I haven't gone all the way around the circle. So I have two options. I can either add everything up, 26, 81, 73, 107, or instead, I know it's going to be 360 all the way around. So I can just subtract the one piece that I'm not using, the 73. So my final arc measure is going to be 287 for that question. And it's definitely a major. I can tell right away. All right, let's take a look at the last ones. PQ, so if I trace that on my circle over here, that's that small arc. We already found the measure of that, 26, and obviously it's a minor arc. Next one, NQ. Let's see if we can find that on my circle. I'm going from N to Q. I'm going the short path. I know NQ is going to be the shorter path here, so it's going to be 81 and 26, which leaves me with 107. Last one I'm focused on is MQN. So I'm going from M to Q, and notice where N is on the circle. So to go to Q, I'm going to be going this direction and then to N. So in this case, I'm not going to be tracing over what I've already traced. All right, I know my answer is going to be between 0 and 360. It's not going to exceed 360. Now, in this case, I've almost covered the whole circle. So I'm going to do 360 minus the one piece I haven't touched, which is 73. It's actually the same thing we had up above, 287. And obviously that one is going to be major. For the next two questions, what they want to know is, are these arcs congruent? So the arc they're referring to is WZ on the larger circle and XY on the smaller circle. Yes, it does appear that both of them are 180. They're both semicircles. But the problem is the radius for these circles, this is the radius of the larger circle, this is the radius of the smaller circle. It's not the same radius, circles are not congruent, so the arcs are not congruent. As I learned from the last problem, I want to make sure my circles are congruent. Well, this piece right here, GF, is the radius of both circle G and circle F. Obviously, it's going to be the same length on both of them. And the arcs they're highlighting, E to F over here, measures 135. And then G to H up top measures 135. So obviously in this case, yes, they are congruent. For this next example, what I'm looking for is the measure of arc LKJ. LKJ. So that would be L to K to J. So I know it's going to be at least 74 degrees because this arc over here is 74. Now the other clue they give me is that this central angle and this central angle have the same measurement. So all the way around 360. We're going to take out that 74, which leaves me with 286 for this arc all the way around, this major arc. Now the thing is, as I said, since those two central angles are the same, right here and here, I'm going to split that 286 in half. All right, what that's going to leave me with is 143 for each of these arcs. So I know that this arc right here is 143 and the top is 143. So just to review, this is what I have: 74, 143, 143. The arc I'm worried about is LKJ. L to K to J. So what I'm going to have to add up is the 74 and the 143. That will give me my entire major arc that I've highlighted here, which leaves me with 217. Next question. What they want me to try to do is solve for x. So they give me 7x minus 12 for this arc right here. This central angle's 5x, which means that this arc over here is 5x. Now they've marked the center in my circle right here, which means that this segment is the diameter, which tells me that this arc that I've highlighted is actually a semicircle. So I know that those two arcs together, 7x minus 12 and the 5x, are going to equal 180. So from here now I just need to solve for x. Looks like x equals 16. Didn't ask me to solve for any of the other arcs, just to find the value of x, which I've done. Now for this final problem, it'll help to sketch out a picture. They're talking about AC, they're talking about BD, they're both diameters in my circle, circle N, and I want to find the measure of these arcs. Obviously, my worksheet's a little messed up. First thing I want to do is draw a picture. So I've drawn my circle. I know it's circle N, so the center is N. Add my two diameters. Now, I'm not really sure where the diameters go, but I do know one is AC and the other one is BD. After that, the only other clue they give me is this right here, this 316. So what they're saying is that from A to C to D, so A all the way to C up to D is 316. Now, my picture is clearly not drawn to scale, but that's okay. I got to figure out what else I know about my picture here. Well, I know that these two arcs are congruent. All right, and obviously the other two arcs are congruent. Right. The other piece I know is that this right here is a semicircle, being that that's a diameter, and then obviously the other side would be a semicircle, or I could focus on the other diameter. Now, if I know that the arc I highlighted in red is 316 and all the way around is 360, then I can figure out this last piece that I haven't highlighted. So if I subtract those two, I'm going to be left with 44. Now, as I said, my picture was not drawn to scale, but this will help me fill in other information. As I said, I know this arc and this are congruent, so they're both 44. The other piece of information I know is that obviously this is a straight angle, all right, or a semicircle. Therefore, I know this angle to the right of it has to be 136, which means this has to be 136. As I said, my picture is not drawn to scale. From here, we can answer what they were asking for. First one was BC, so arc BC. We already filled that in. It's going to be 44. And the last one they want is DCB. And it looks like D to C to B is semicircle.